and it is on reverse syllogism, right? What is reverse syllogism? Usually in syllogism, we are given statements and we have to find out which of the conclusions logically follow the given statements. Yeah. But here in reverse syllogism, we are given the conclusions. The conclusions are true. We have to find out for which of the set of statements will these conclusions be true. Right? So reverse process. Now, no point in drawing the diagram for the conclusions, right? You never draw a diagram for conclusion. You always draw a diagram for the statements. So look at the conclusions. He says no car is a bike. All bikes being races is a possibility. He's talking about two conclusions where he says no car is a bike and all bikes can be races. All bikes being races is a possibility. So let's check the statements. Yeah. See, very clearly, there are some techniques which can help you eliminate some of the answers directly. Like if you observe the first conclusion here, he says no car is a bike. No car is a bike. Car and bike cannot overlap at all. No car is a bike mean what? Car and bike should not be touching at all. So whatever diagram you draw for the statements, cars and bikes should not be touching at all. No car is a bike. Now just by reading some of the statements, we can eliminate. See, statement 1, the first option here, set of statements says all cars are bikes. If all cars are bikes, can the conclusion be no car is a bike? No, so it is wrong. Directly eliminated. Similarly, statement 3, all cars are bikes. If all cars are bikes, can the conclusion be no car is a bike? Eliminated. Anywhere else we have all cars are bikes? No. So directly we have been able to eliminate 1 and 3. So this way you can eliminate some of the options. And if you are lucky and able to eliminate, let's say 4 of the options, you are done. Without drawing any diagram, you can conclude that. You can come to the right answer. You can arrive at the right answer. But anyway, since only 2 of the options have got eliminated, we have to work on this one. Right? How did we eliminate option 1 and option 3? Not option 1 and option 3, but statements 1 and statements 3. Because statements 1 and 3 have got all cars are bikes as one of the statements. If all cars are bikes, then the conclusion cannot be no car is a bike. These are quite opposite, right? So 1 and 3 are eliminated. Now draw the diagram for 2, 4 and 5. Anything else that we can verify? I don't think any direct verification otherwise is possible. So draw the diagram for statements 2. Statements 2. Some matches are bikes. Some matches are bikes. No bike is a race. No bike is a race. Bikes and race do not touch each other. All cars are laps. All laps are races. All laps are races. So I think I'll have to just redraw this in a bigger way, right? 1 second. So what is it? All laps are races. All laps are races. All cars are laps. So it's like this. All cars are laps. All laps are races. And no bike is a race. So that's a diagram for statements 2, right? What does it say? Some matches are bikes. Some matches are bikes. No bike is a race. See, bike and race do not touch each other. All cars are laps. All the cars are laps. And all laps are races. All the laps are races. Now check whether the 2 conclusions given here satisfy this basic diagram or not, right? We have drawn the basic diagram for second set of statements. So no car is a bike. Is it true? Yes, no car is a bike is true. Because if bikes cannot touch races, bikes will not be able to touch cars. Very clearly, right? If bikes cannot overlap with races, how will bikes ever overlap with cars? Because the moment bike overlaps with cars, it also overlaps with races. So first one follows. First conclusion follows. Second conclusion, all bikes being races is a possibility. Can all the bikes be races? No. Clearly he says bikes and races cannot overlap, right? No bike is a race. No bike is a race. So if no bike is a race, how can we say all bikes being races is a possibility? I think we have got one more way to eliminate the options. Yeah. Now it gives me a clue. See, no bike is a race. If no bike is a race, how can we say all bikes being races are possible? Impossible, right? Bikes and races do not touch at all. So statements 2 also get eliminated. And the moment statements 2 get eliminated, I think statement 4 also get eliminated because it says no bike is a race here. See, when no bike is a race, how can all bikes be races? Let me highlight. Let me use a highlighter here. See, no car is a bike. We eliminated 2 options. All cars are bikes and all cars are bikes. So these 2 options got eliminated because these are not going together, right? Similarly, if you look at the second set, let me use a different color here, right? He says all bikes being races is a possibility. How is it possible when you have given no bike is a race? You are very clearly given that no bike is a race. So how can all bikes be races? Similarly, no bike is a race. How can all bikes be races? Not possible, right? So I think we can directly eliminate 4 options. Like what I mentioned earlier, right? If you are lucky, you can eliminate 4 options straight. So 1, 2, 3 and 4 have got eliminated. 1, 2, 3 and 4 have got eliminated. Then only 5 is left out, which is not there in the options at all. Yeah, I think the answer should be option 5, none of this. Because the correct answer is, correct answer could be statement 5. Let me check statement 5, by the way. Let me check if statement 5 gives you the answer. All matches are bikes. All matches are bikes. No bike is a lap. No bike is a lap. All cars are laps. All cars are laps. All laps are races. All laps are races. Yeah, that's the diagram for statement 5, right? All matches are bikes. All the matches are bikes. No bike is a lap. No bike is a lap. Yeah. All cars are laps. All laps are races. Now check the two conclusions. No car is a bike. Yeah, no car is a bike is correct, because bikes cannot overlap with laps. If bikes cannot overlap with laps, bikes cannot go inside laps and overlap with cars. So no car is a bike is true. Yeah. Simple, right? Bikes cannot overlap with laps. So how can bikes overlap with cars? Yeah. Then second conclusion was all bikes being races is possible. All bikes being races is possible. Yes, definitely possible, because if I draw races in this fashion, what happens? R dash. Sorry. If you draw races in this fashion, R dash. Any problem? No problem, because statements have not, we have not gone against the statements, right? Statement said all matches are bikes, all the matches are bikes. No bike is a lap, no bike is a lap. All cars are laps, all cars are laps. And all laps are races. So instead of drawing all laps are races in this fashion, we have drawn all laps are races in this fashion. Possible way of drawing races, right? This is a possible way of drawing races, R dash. The moment I draw R dash, all bikes being races becomes possible, right? All the bikes are races. You see, all the bikes have become races. So it is possible. All bikes being races is possible. Yeah. When you consider statements 5, set of statements 5. So I think answer should be option 5, none of this. And the exact answer should be only statements 5. Only statements 5. Yeah. So I think there is an error in the options here. All the four given options are wrong. So I am taking fifth option. I am creating a fifth option, which is none of this. What are the statements? All doors are windows. No clip is a window. So draw the basic diagram. Don't write basic diagram in your exam, okay? Don't write these two words. Don't waste your time. Now don't ask me why am I wasting my time then, because I have to explain it to you. All doors are windows. All doors are windows. No clip is a window. No clip is a window. That's a basic diagram. All the doors are windows. So all the doors are inside windows. And no clip is a window. So clips and windows will not overlap each other. So that's the reason we have put this cross marks, right? Now, conclusion number 1. Some clips, if they are doors, they're also window. Some clips, if they are doors, they're also window. Well, some clips, if they are doors, they're also window. No. I think very clearly in the statement he has mentioned that no clip is a window. So forget about this if clause, right? If they are doors. Clips cannot be doors in the first place. As per the basic diagram, clips cannot be doors. He says some clips, whatever condition, are also window. Is it possible? Clips being windows is possible? No. Very clearly the data says no clip is a window. Statement says no clip is a window. So some clips, whether they are doors or not doors, can never be windows. Clips can never be windows, because no clip is a window. No clip is a window. So some clips are windows is wrong. First conclusion does not follow. Right? First conclusion does not follow. Second one, all clips which are not windows are also doors. All clips which are not windows are also doors. No, so forget about this. All clips which are not windows. So in the current basic diagram, all the clips which are not doors, which are not windows, are these clips. If you understand, let me highlight this. We are referring to this yellow shaded part of the statement. All clips which are not windows. All clips which are not windows. What are the clips which are not windows? All these clips are not windows. Now he says, read it as yellow now. Yellow are also doors. Yellow are also doors. Is it true? No, yellows are not doors. You understand? I have highlighted some part of the statement in yellow. The same yellow highlight has been done in the diagram. So this is the text highlight, this is a diagram highlight. According to text, yellow are also doors. Is it true in the diagram? Yellow are also doors? No. Yellows and doors cannot overlap at all. So second one also is wrong. Yeah? So the answer should be none follows.